Unit 3, Day 4, we're going to talk about equations of quadratic functions, and what we mean by that is I'm going to give you 3 points, and you need to tell me what's the quadratic function that goes through those 3 points. Okay? So our learning target is I can model data with a quadratic function. Suppose we have these points, 2, 3, 313, and 429. And as you look at this, as the x's go up, 2 to 3 to 4, look what's happening to the y's. They went from 3 to 13 to 29. They're increasing pretty fast. The y's are going up a lot faster than the x's are. So when it says, are they linear? Well, if they were linear, when the x's go up by 1, the y's should go up. Say if it went up by 10, it should go up by 10 again. So if it went from 3 to 13, it should go to 23 if this is linear. So that the ratio is the same. The x increases and the y increases. So these are not linear. Like I said, from 1 to 2, from 2 to 3 is plus 1, from 3 to 4 is plus 1, from 3 to 13 is plus 10, but then from 13 to 29, that's plus 16. That's a much bigger jump. So every time x goes up by 1, y goes up by more than it did last time. And so most likely that's probably quadratic. And if we were to plot these guys, we could probably see that. In fact, well, maybe let's get back to that. I'm going to put it is yes. And if we get back to that, I'm going to show you how to look at that. Okay, so find the equation of the parabola. So they're telling you it is a parabola that goes through these 3 points, 0, 5, 2, negative 5, 4, negative 3. I'm sorry, negative 39. How in the world would we do that? So what we want to do is we want to look at standard form. So ax squared plus bx plus c. Okay, and we have x's, we have y's, and we have a, b's, and c's. We have a lot of variables here. But here I got a pair of x's and y's, and then another pair of x's and y's, and another pair. So 3 different pairs I can plug into this. So I could, using this right here, I could plug in x, I could plug in 0 for x and 5 for y. So I'll plug in 5 for that y. And then for this x, 0, because x equals 0. I have that. I have a's, b's, and c's to solve for. Now this one is a unique one in that these all wipe out. So 0 squared is 0, so 0 times a is going to be gone. 0 times b is going to be gone, and you're left with just c. So actually c equals 5. This is one of those rare cases where you can find one of your points right off the bat. And that happens whenever you have an intercept. If I give you, in this case, this is 0, 5, that's the y-intercept, okay, because x is 0. Now let's do it again with this point. So here's an x, here's a y, whoops, here's a y. And so I'm going to have negative 5 on the left side, and then for all the x's, plug in 2. And then do it a third time. So I'm going to plug this one in. So x, y. And plugging in 4 for the x's. And I get that. And notice I have a system of 3 equations with 3 unknowns. Okay, so we did some of these. You guys didn't like them. That's okay. But we did some of these where we solved systems of 3 equations, 3 unknowns. We had x, y, and z many weeks ago. I think it was in the first unit. We had x, y, and z, and we had 3 equations, and we had to combine 2 of them together, combine these 2 to get rid of a certain variable, combine these 2 to get rid of the same variable, and then you got a system of 2 equations, 2 unknown, and keep going. But the cool thing about this one kind of speeds up because that first equation simplifies, again, 0, 0, so this is 5 equals c. So right off the bat I can fill these in. This would be, let's see, I'll do this, arrow over. So negative 5 equals, that'd be 4a plus 2b plus 5. And then here to have negative 39 equals 4 squared 16, so 16a plus 4b plus 5, because c equals 5. Okay, now I've got 2 equations, 2 unknowns. If I did some simplifying here, in fact, I think I'm going to come over here, so I'm running out of space on that side. But if I bring this 5 to the other side, so I subtract 5, that'd be a negative 10 equals 4a plus 2b. And then subtract this 5 over, that'd be a negative 44 equals 16a plus 4b. and I want to wipe something out here. So I'm going to take this top one times -2. So this would be positive 20 equals negative 8a minus 4b. Negative 44 equals 16a plus 4b. I'm just rewriting that bottom one. Notice the b's cancel out. So 16a minus 8a would be 8a. And this would be a negative 24. So it looks like a equals negative 3. So I got C and I got A. Now I just need to find out what B is. Doesn't really matter. I might let's look at this guy right here, this first equation. I'm going to have negative 10 equals 4 times negative 3. So 4 times negative 3 plus 2b. So this would be a negative 12. So I'm going to add 12 to both sides. So those wipe out. I got 2 equals 2b. It looks like b equals 1. Okay, so that's kind of the long way of doing it. And so what this is, if I plug these in now, I should get my final answer. My final answer is y equals negative 3x squared plus 1x plus 5. If you put those on the calculator and check it, it does go through those 3 points. So if I graph, and if you remember how to do this, if you go y equals negative 3x squared plus, I can just put x plus 5 and hit graph. I'll get a parabola and I want to check, does it go through these points? And the fastest way to do that is to, my video froze, is to hit trace. That's one way of doing it. And you could, like right now, 0, 5. 0, 5 is one of my points. Then if I want 2, negative 5, hit 2, enter, negative 5. And then 4, enter, negative 39. So it does go through those 3 points. So that is the long way of doing it. Okay. So now I do want to show you a shorter way of doing that. And on the homework, I do want to see, it's going to ask on Math Excel to show your work. And what I mean by show your work is I want to see this initial system that you set up. So this right here, I want to see that you know how to set that up. I'm not going to ask you to solve it every time because that does take a long time. So think x, y, x, y, x, y. And here's your standard form up here. So my first y is 3. 3 equals a 2 squared, because 2 is your x, plus b times 2 plus c. The next point, I'd have 13 for y, and then 3 for x. And the last one is 29 equals a 4 squared plus b times 4 plus c. And then from there, so I do want to see you set that up. I wanted to know that you know how to set that up, and hopefully if we know how to set, or since we once learned how to do 3x3s, we're going to assume we still know how to do that. But now there's a faster way in the calculator. So these are going to be some new steps. I want to get this to where you can see the buttons I'm pushing too. So first, you may want to write these down. We want to put in some lists here. I want to put these points in as a list. So I'm going to push stat and then edit. So the first option, so it's going to hit enter. And let me clear these out. And my first list, I'm going to put all my x values in. So I'm going to put 2, 3, and 4. Sorry, my lights just went off. So 2, 3, and 4. And my y values are 3, 13, and 29. So 3, 13, 29. And now, there's this thing called regression. We're looking for a best fit line. You probably learned in Algebra 1 about a best fit line. What we do with this, we're going to go back. If I can get my buttons on the screen here. I got my list in. So 2, 3, 3, 13, 4, 29. Push stat. Go over to calc. So I'm pushing over to calc. And I want quadratic regression. Okay, so I'm going to look in that quad means quadratic, and the regression is going to find the best fit line that goes through these 3 points. So I hit enter. For the X list, I want L1, which is probably yours is already. Now, if it was not, you would want to push if you see right above these, we have an L1, L2, L3 above the buttons. You'd push second and then the number 1, and that gives you the blue. So the second button is blue, and that's blue. So second L1, if it's not already that. I'm going to go down, and you could really just skip down to calc. After my video catches up, there you go. So there is your A is 3, like I said before. Wait, did I change these? Ooh. Sorry, these are not the same. I got the wrong problem. I'm pointing above to that. These are different points than number 1. So this would be my A. So I'd have y equals A is 3. So 3. Put this over here so you can see it. 3x squared plus my B is 5. So I already want to put negative 5x. So it's a negative. And then plus 1. And there'd be my problem. So try those steps again with this one down here. So pause your video right now. Try this. Try to do all the same steps over again. Get an answer and then hit play and see if you got the right answer. So anyway, this is the answer. So hopefully you did check it, try it out. And again, for the work part, it says show work, write this in. Okay, that's what I want to see. So on Math Excel, we're going to practice that where it says show work. There is a way to type it. Maybe I can find one of those. Okay, so here's our screen. When you open it up, hopefully this is recording still, it'll say for work, show me the system you set up. And that's what I was talking about, just the system. When you go to show work right here, I know if you click here, you can actually type what you want to type. Go like this, and you can start typing like I want 6 equals, and then A negative 1 to the second, and so on. And you can type your equation like that instead of writing. So maybe that'll be more helpful for you.